Hello and good afternoon, everyone. I hope you're all doing very well. And thank you for taking time to join me on this Global Market Access webinar. My name is Charlotte Pemberton Bennett, and I'm the Global Market Access Manager here at TÜV UK. At TÜV we specialise in providing testing, certification, and global market access services for a wide range of product industries. And my role in particular focuses on helping manufacturers navigate the often complex global regulatory landscape to ensure your products can be sold worldwide with minimal delay and risks. I've had the pleasure of working with many different companies in the past 2 years since I've started here as they bring their products to market across the globe. And I've seen firsthand the challenges that can arise when compliance planning isn't considered too early enough and is left too late in the development process. So this webinar is designed to hopefully help you avoid the pitfalls that pop up and set your product up for global success right from the start. Now let's take a quick look at what we're going to be covering today. We have a packed agenda, as you can see, with lots of different topics to explore. We're going to start by discussing the importance of compliance planning and how it's something you need to address throughout product development so you avoid issues further on. And we'll talk about how early planning can help you avoid those costly delays and redesigns down the road. From there, we'll move on to module integration. As more wireless technology is embedded into products, choosing the right RF module and understanding its certification requirements is essential. I'll explain how pre-certified modules can potentially save you time and simplify the compliance process. After that, we'll touch on frequency planning. Different countries have different rules for how wireless products can use the radio spectrum, and we'll go over how to make sure your product is configured to meet those variable regulations. We'll also cover the key documentation requirements you'll need to meet, everything from test reports to user manuals to block diagrams. It's not just about ticking boxes to comply with regulations, but having the right documentation in place is crucial to ensure your product gets certified straight away without any issues. Next, we'll discuss some common compliance pitfalls that manufacturers often run into. These are mistakes that can cause delays, increase costs, and sometimes even lead to product failure, but they're avoidable if you know what to look for. To bring all these concepts together, we'll then walk through a case study together and we'll show how everything we've talked about works in practice, and this will hopefully give you a real-world example of how smart planning and careful execution can make the compliance process a lot smoother. And finally, we'll wrap up with some best practices for global compliance, highlighting a few key strategies that can help you minimize risks and ensure a smooth path to market. After we've covered all this, I'll open the floor to questions. So feel free to submit your questions in the chat box as we go along or at the end as we wrap things up, and I'll answer as many as I can at the end. Now, let's dive into our first topic, compliance planning. This section is really the foundation of everything we'll be discussing today. Getting compliance right from the start, as I said, is going to save you time, money, and headaches later on. And by being proactive and considering compliance early in your product development, you're setting yourself up for a much smoother path to market. One of the most common mistakes I've seen companies make is leaving compliance planning to the later stages, and it's understandable as there's a lot to focus on in the product design and development as a whole. So that getting ready for testing for compliance can sometimes feel like something you have to deal with after the fact, but waiting too long can lead to significant delays and costly rework. So let's have a look at my example here. On the left, you have company A that is only considered 4 markets during development. So they're focusing on the main tier 1 countries, EU, US, Canada, and Japan. But later they realize that they want to go into South Korea, America, or Malaysia. And unfortunately, these regions have different regulations, different frequency allocations, and different flat power limits and documentation needs. So as a result, because they haven't prepared at the start, they're now having to spend additional time testing and doing further work to get into those markets. And on the right side, you can see a company that has taken quite a different approach. From the outset, they've planned for all the possible markets they possibly will want to sell into. They've researched the regulations and built their products to meet not only EU and FCC standards, but also consider future markets like Asia Pacific region or South America. And because they've thought ahead, their products already meet the varying compliance requirements across the region. So when they're ready to expand, there are no last minute surprises and their market entry is much smoother. So the lesson here is hopefully clear. Early planning for global markets can prevent costly rework and delays, and helping you get your product into more markets and faster with few headaches. Now let's talk about model numbers and part numbers. Now these may seem like simple identifiers, but they play a really critical role in tracking product variants and ensuring proper compliance in every market. Now, just as a refresher for those that you don't know, A model number is a unique identifier for the entire product. It represents the core design, the functionality, and the feature set of that product, regardless of any variations that may exist in such things like different colors or size. This is the model number that will need to appear on your product label and in your documentation, and it's a constant that needs to exist across all your product documentation. On the other hand, a part number is much more specific and is used to differentiate between specific variations of the product. For example, let's say you're manufacturing a wireless device that has slightly different sizes, slightly different colors, slightly different power inputs. The model number for all these versions would need to stay the same, but those variations will be covered under a part number. So why am I talking about this, and why does this distinction matter? Well, lots of manufacturers confuse the two. Model numbers need to be used for regulatory purposes and need to be in your compliance documentation. Part numbers, on the other hand, almost need to be removed from the compliance process altogether and just be used for your internal tracking purposes in order to understand the differences. When you're conducting the compliance testing, it's really important just to use the model number. As I've seen many companies make the mistake of listing part numbers on the test report, which means that instead of having to do one certification, you're having to do 5. For example, if we take a look at the diagrams below, often manufacturers tend to list their part numbers something like 123-XX or 456-XX, and given the number of units and variations that exist. Now, if you do include this suffix in your test reports, this can raise flags, and a regulator might assume that all the units with different suffixes on the end, not just XXX, whether it's 123-ABC, BCD, and so forth, each of those part numbers are going to require their own separate certification in some countries. But if you use your model number across all of it, you can streamline the process and then get a single certification across all your multiple variants. So please make sure that your model numbers are consistent in your compliance documentation and keep the part numbers for internal purposes. Now, moving on to a similar vein, we're going to talk about product families and variants. Many of you are probably developing product lines that consist of multiple related models that are common, that share a common design but differ in specific features. For example, one might have a high performance battery, while another version might be as basic as a different size or color. When it comes to compliance, this concept of product families can sometimes work to your advantage. In many cases, you can leverage the test results from one model to certify the other models within the same family, as long as the variations don't affect critical aspects like RF performance or safety. Regulators in some regions also will allow you to reuse these test results, and this can save you a tremendous amount of time and money because you avoid having to retest each variant individually. However, there is a balance. In some regions, even a small change like a switch on an antenna or a chipset can require additional testing and may prevent you from leveraging certifications. Now, as an example, in the EU, if you have a product family with multiple versions, you likely will be able to test the worst case variant to cover all the other versions. This is particularly useful if you have one model that draws the most power or uses the highest performance features. And by testing the worst case scenario, you can cover the more basic depopulated versions of the product, saving both time and certification costs. But it's important to remember that not every region allows this. In some markets, even the slightest change will require a new certification. So even if you've tested the worst case, you're likely going to have to do a certification for each of the family models. So the key here is to know where and when you can reuse the certifications and where you'll need to certify each variant individually. And by planning this in advance, you can hopefully optimize the process and avoid unnecessary costs. Now let's talk about branding and how that impacts compliance. Many manufacturers don't realize that the product's branding can actually influence the certification, particularly for global market access, when you're dealing with multiple markets. For instance, some countries require that the brand name is listed on the approval certificate, and so that needs to be included in the compliance documentation that you submit. So this means if you're using a particular brand name in your marketing materials or product labeling, that needs to be in your test report, and any discrepancies can result in delays as regulators ask questions, and sometimes can result in recertification or retest or reopening your test reports to fix the information accordingly. Additionally, if you're a manufacturer that plans to market your product under multiple brand names in different regions, you're also going to have a think about how that's going to affect your testing and documentation. In some cases where brands are listed on the certification, you might need to conduct separate certifications for each brand name. For example, Malaysia mandates this. This is something to keep in mind if you're planning to enter certain markets where trademark and branding regulations can also vary, particularly when you're looking at trademark laws and marketing regulations overall. So overall, to summarize this section, the key takeaway is be early and be thorough and be consistent, whether it's understanding the difference between model numbers and part numbers, managing your families and variants, or ensuring that the brand names are compliant with regional regulations. All of these factors need to be considered well before you enter the market. So by planning this early, you can avoid all the pitfalls that I've mentioned later on. Now let's move on to module integration, which is a critical aspect of wireless product development. How you choose to integrate your RF module will directly impact your product's time to market, your certification process, and your overall performance. And these decisions you make can save you both time and money, but as always, they come with trade-offs. And we're going to discuss the three main groups, which is onboard circuitry, full module integration, and limited module integration. And each has its own advantages and challenges depending on your business goals and compliance needs. Now let's start with onboard circuitry, where you design the RF components, such as a Wi-Fi or Bluetooth, from scratch and integrate them directly onto your product's PCB. This is a great option as it gives you complete control over the design and performance of your product, allowing you to tailor the RF circuitry to meet your specific needs. And you can adjust power output, signal strength, and fine-tune the circuitry to meet your performance goals. However, this approach comes with significant compliance challenge. Since you're building the RF components yourself, you'll need to go through full compliance testing and certification for each market that you're targeting. This includes RF emissions, conductor emissions, and radiated emissions, electromagnetic compatibility, and safety testing. So it can be quite a lengthy and costly process because every component of the RF design will need to be scrutinized by regulatory bodies. Additionally, with the onboard circuitry, regional variations in frequency use and power limits can also complicate things. Expanding into new markets may require software updates or redesigns to meet those specific regulatory requirements. So this approach is generally best suited for manufacturers who have in-house RF expertise and the resources to manage the extensive testing and certification required. Now, on the flip side, you can go with full module integration, which is similar to a single modular approval if you're looking at FCC. This approach follows a pre-certified RF module that has already passed most of its regulatory testing. The module is certified for use in a variety of host devices, meaning you can integrate it into your product without repeating the entire certification process. The biggest advantage of full module integration is that it significantly reduces the amount of testing required. You can reuse the module's existing test reports for a lot of the regions, which saves both time and money. And by following the module manufacturer's guidelines of things like antenna placement and power output, you can ensure the certification remains valid. That said, there are trade-offs. Full modules limits your ability to customize the RF design, and while the module is already certified, you might encounter in higher costs per unit compared to designing your own components. Despite these limitations, this approach is ideal for companies that are prioritizing speed to market and want to minimize regulatory risks. Finally, there's limited module integration. In this case, the module might be pre-certified, but it will have much more specific conditions, or as it might be certified for use certain host devices or under certain specific operating conditions. If you deviate from these conditions, such as changing the antenna or the housing or the conditions, you can invalidate that certification, which essentially brings you back in line with a certification as with onboard circuitry. With limited module integration, however, you can still reuse some of the test reports to cover some of your compliance, but you'll need to perform additional testing if you plan to modify the module. For instance, if you change the firmware or make adjustments for regional requirements, as we're going to touch on frequency planning, additional certification might be necessary. Now, this approach offers more flexibility than full module integration, as it allows you to tailor the product a little bit more, but it also requires much more careful management of the certification process. So this is kind of a good approach if you're targeting specific markets first and then potentially planning to expand into others later on. Now, when integrating an RF module into your product, there are several technical factors that you'll need to consider carefully. These factors don't just affect performance, they also impact compliance and certification. Firstly, let's talk about antenna design and placement. The placement of the antenna can make or break your product's RF performance and can affect your product's compliance with RF exposure limits and emissions regulations. For example, if your antenna is placed too close to metal components or is enclosed in a particular type of casing, it can cause signal attenuation, reducing your product's range or creating interference issues. Regulatory bodies like the FCC and ICED are particularly strict when it comes to antenna performance, and in many cases, changing the antenna or even slightly adjusting its placement can sometimes trigger the need for retesting. So the best practice, as always, is to follow the module manufacturer's guidelines. They've already optimized the antenna design for compliance, so any deviation from their placement, gain, or type may result in non-compliance. Now, moving on to RF power. Power output is very regulated and is something that the GMA team focus on a lot, particularly in the unlicensed bands like 2.4 gigahertz and 5 gigahertz, which are commonly used for Wi-Fi and Bluetooth or Zigbee. Different regions will have different maximum allowable power levels to ensure the devices don't interfere with other frequencies on the spectrum. For example, the FCC allows higher output powers when compared to EU, but both have stringent limits that you need to adhere to. And if you exceed them, you're going to fail your certification. Or if it passes and then finds higher later on, you might be picked up in market surveillance, which can lead to fines or forced recalls in the market. So you need to ensure that the RF module you choose and how you integrate it meets the power output requirements of the regions you're targeting. Fortunately, for those of you that might be selecting pre-certified modules, often the module manufacturer will have a built-in firmware that you can use pre-power levels, but if you're using onboard circuitry or modifying the module, you'll need to do thorough testing, confirm compliance, and make sure your software is updated accordingly. Now, another critical consideration is frequency planning and channel usage. Different countries and regions allocate frequency bands in different ways. For instance, the 5 gigahertz band is much more regulated than the 2.4, and certain channels are restricted or require dynamic frequency selection to avoid interference with radar systems. So if your product is using a restricted channel, you may need to disable it through your firmware in certain regions. And when integrating a module, ensure that its frequency capabilities align with your target markets, as there are some countries, which we'll touch on later, that have certain bands closed. So if you want to use that band in that country, you need to make sure that the module is capable of that, or is capable of operating in alternate bands that you need to operate in. Another factor that's often overlooked in module integration that we get hit on a lot is user proximity. For wireless products, especially those operating in high power bands, such as cellular devices, you'll need to demonstrate compliance to specific absorption rate or demonstrate you comply with RF exposure guidelines. Those requirements ensure that users aren't exposed to harmful levels of RF radiation when using your product. For example, if you're developing a wearable device like a smartwatch, you'll need to prove that the product's RF emissions remain within safe limits when in close contact with the user's body. And this often requires specialized testing, the DAISY device, and if you change anything about the module or antenna design, that can affect the results, meaning you might have to retest the product for compliance again. Now that we've covered some of the technical consideration, let's go over some of the best practices that will help you avoid things. So first, whenever possible, if you're going for quick and easy, use a pre-certified module. This will drastically reduce your time to market because much of the compliance testing has already been done. Sometimes even the certification has been done as well for certain countries. By using a module that's been certified for those major markets, you only need to focus on testing how the module works within your product rather than starting from scratch at a conducted level. However, make sure, again, you follow the module manufacturer's guidelines, and any deviation, once again, will void the module certification, meaning you have to start all over again. Second, ensure you optimize antenna placement for both performance and compliance. Poor placement can affect both signal strength and compliance with regulatory limits, especially if your device is operating in high density environments or is sold in regions with stricter EMC or RF exposure rules, with Chile as an example. Finally, don't forget to conduct EMC and coexistence testing. This ensures that your product doesn't cause interference with other devices and that it can operate in the presence of other wireless technologies. This is particularly important for products that operate in crowded frequency bands. Now let's dive into a bit more detail and have a look at the specific considerations for markets like EU, US, and Canada. Each of these regions has its own regulatory framework for wireless products, and understanding the difference is essential to getting a nice smooth process. In the European Union, manufacturers often need to use a self-declaration process for compliance under the Radio Equipment Directive. This means that you're responsible for ensuring that your product meets the relevant standards. One advantage here is that if you're integrating a pre-certified module, you can reuse the conducted RF test reports from the module certification to cover large portions of the required testing. However, the EU still requires you to perform additional tests, such as radiated emissions, to ensure that your product as a whole, with the module integrated, meets the EU standards for EMC and RF performance. It's also really important to make sure that you have a technical construction file in place that includes all your test reports, all your declarations, which you'll need to keep for potential audits and market surveillance. Now, moving on to the US, products need to comply with the FCC's Equipment Authorization Program, which typically requires formal certification through a recognized testing laboratory like TÜV SÜD. For products integrating RF modules, you can reuse some of the module's test data and leverage the certification, but you'll need to perform additional testing, especially if you've made changes to antenna, power output, or the operating frequencies. Once the testing is complete and you meet all the required standards, you'll receive an FCC grant of equipment authorization, which allows you to legally sell in the US. And then you need to make sure that your product is properly labeled with the FCC ID on the product. One thing to note about the FCC, however, is for those of you who are concerned about confidentiality, the FCC does list the grant publicly on their portal. So if you are concerned about that, make sure to apply for confidentiality, which usually lasts around 6 months. Unfortunately, you can't hide forever from public review. Now, Canada follows a similar process to the FCC with their regulatory body, the Innovation, Science and Economic Development Authority. Again, you can reuse the test data for pre-certified modules, but you'll need to ensure that it complies with Canada's radio standards. Like the FCC, and ICED also has specific rules around antenna performance and power levels. And in some cases, certain channels in the 5 GHz band are restricted in Canada, such as band 3. So it's important to make sure you adjust your firmware accordingly, as it does differ from the US. Once testing is complete, much like the FCC, you'll get your ICED certification number to label your product accordingly. Now, I've just touched on this a little bit before already, but do kind of want to emphasize this a bit more, as there are two critical types of RF testing that require for most wireless products: radiated and conducted emissions testing. And these two are essential for ensuring your product operates within the regulatory limits and doesn't cause harmful interference with other devices. Now, conducted emissions as a whole measures the electrical noise that is conducted into the power supply or wiring system. And this type of testing ensures your device doesn't cause interference with other devices sharing the same power source. Now, when integrating an RF module, you can use those test results because it is all wired and it's not doesn't have any effect on the end product's operation if you've matched it all. However, if you're making any changes to the antenna or circuitry, you'll need to repeat this again for your end product. Now, radiated emissions testing focuses on electromagnetic energy that is unintentionally radiated from your product into the surrounding environment. Now, this is crucial because too much interference can disrupt other devices operating on similar or nearby frequencies. For example, in the 5 GHz band, regulatory bodies like FCC, ICED, and EU have strict limits on how much RF energy can be radiated by the device. And the goal of radiated emissions is to ensure that your product doesn't exceed these limits and cause interference in the field. This is the part of testing that cannot be reused by the module, because depending on the enclosure you put the module into, that can have an impact on how the RF signal radiates from the device. So you can't use the results that the module itself has used because it's an entirely different environment. A best practice here overall, as you're integrating module, is to preemptively work with a test lab or in your own chambers, so you can understand what your results are likely to be, and as you investigate the regulatory requirements in your target market. So testing early in the design process can help you catch issues like antenna misplacement or excessive power output, allowing you to correct them before you go through formal testing and certification. So it will save you cost, time, and resources overall. So now that we've covered the key compliance requirements for EU, US, and Canada, let's take a step back and look at the broader picture, which is everything in the global market. Expanding into global market can be really rewarding, but it also comes with a very unique set of challenges. While many regions will share common testing protocols thanks to the ITU and certification requirements, there are lots of local differences that will need to be navigated carefully. One of the first things to be aware of is all the different certification marks that come with wireless approvals that are required in various regions. For instance, many of you will likely all be aware of CE and FCC IDs and ISED marks, but beyond these, regions such as Asia and South America have their own marks. As you can see here, working from the top to the bottom, we have Japan's JITEKI mark or TELEC mark, and then we've got Taiwan's NCC mark, Korea's KC mark, Argentina's Ramatel mark, and then closing it off with Brazil's Anatel mark. All of these marks are essential for market entry in the associated countries and need to be displayed on your product. There are exemptions for those of you who have smaller products, but you need to ensure that if there is room to put a label on, you put their label on as a priority. Failing to include the correct marks can result in a delay at customs or even prevent you from selling the product in the first place in the country. Additionally, as you expand globally, it's important to recognize the regulatory requirements and how they differ. While some countries may accept test results for EU or FCC, with Argentina as an example currently accepting FCC test reports for cellular bands, others will require testing locally or will have additional national standards to meet. For example, Japan and South Korea have their own specific rules for RF emissions and power limits that will differ from the ones you've already met in the EU or the US. So overall, there's a delicate balance between harmonization and customization of standards when planning for global market access. Some regions like EU and US will have harmonized certain standards, meaning that products certified in one market might have a smoother path to certification in another. However, in many cases, you will need to customize aspects of your product to meet local regulations by adjusting power levels or disabling certain frequency channels. So global compliance as a whole is often working with your firmware team to customize your software or making minor design changes to align with all those differences. Finally, when entering new markets, it's crucial to stay informed about ongoing regulatory changes. Countries regularly update their standards as technologies evolve. It's something we see day in, day out in the GMA team. For example, markets like India, China, and Brazil are constantly adapting their rules to accommodate new wireless technologies, spectrum reallocation, and environmental standards. So keeping up to date with these changes ensure that your product remains compliant over its life cycle. So working with local partners or people like TÜV-SÜD, we can help you stay up on top of these updates and adjust your compliance strategy as needed so you have the longevity of compliance rather than having to redo certifications as a country adds IPv6 requirements or cybersecurity requirements further down the line. So in summary, going to global markets requires thorough planning and understanding the local nuances of each region. So by navigating all of this, you can position yourself for good success. So now that we've discussed the broader global considerations, just want to have a look at specific global certifications that you'll need to be aware of. On this slide here, you can see TÜV-SÜD's wonderful global market access map, which highlights some of the conformity marks required around the world. On the map here are the main big heavy hitters, including some of the energy efficiency and safety and EMC marks that may also be required in addition to the wireless marks. As you can see, each country has its own regulatory body and certification mark to demonstrate compliance with their own standard. What's important to note here is while some regions might accept test reports, so as you can see, if we go geographically, so South America typically accepts your FCC test reports. Moving across to Europe, you've got Africa and the Middle East aligning more with EU test reports and accepting that as data. And then as you go further and further east, there's less and less acceptance and more national standards and deviations coming into place. So that's why planning ahead and having a good understanding of what the global regulatory landscape looks like is so crucial. So now let's dive into frequency planning, where we're going to have a look at how to ensure your product meets the regulatory requirements for wireless frequencies across different regions. As already mentioned, wireless regulatory regulations vary a lot from country to country, and failing to plan for these differences can lead to costly redesigns, compliance failures, or limited market access. So to kick things off, we're going to keep things nice and simple, hopefully, and just keep it on the 5 GHz band. which is widely used for Wi-Fi and other wireless communications. So as you can see here, we've got a nice colourful chart of some big heavy hitters in terms of regulations, sort of just to hopefully highlight the complexity of frequency regulations and why it's essential to plan ahead. So on the right-hand side of the slide, you can see Europe and US, China, Canada, South Korea, Malaysia, Mexico, Japan, Brazil, and Argentina. And as you can see, there isn't much similarity at all between any of them. In Europe, for example, with the 5 gigahertz divided up into the 4 bands, DFS is required for portions of the spectrum, like 525 to 5350 megahertz and 5470 to 5725 megahertz. As I mentioned before, this means that your product needs to be enabled to detect radar signals and automatically switch channels to avoid interference. In the US, in contrast, DFS isn't required for any of the bands, but higher output powers are allowed for outdoor use, which can be helpful for those of you who are wanting to use long-range communication. In China, by contrast, there is much stricter restrictions. As you can see, the 5 gigahertz band is also limited to indoor use, and only certain portions of the band are available, with band 3 completely closed. This brings us to another key consideration, the difference between indoor and outdoor use. Many countries like Europe and South Korea will impose specific restrictions on outdoor use for certain parts of the 5 gigahertz band. This means that if your product is intended for outdoor use, you need to ensure that it complies with those regional power limits and the spectrum usage rules to avoid fines and compliance issues. For example, in South Korea, like in Europe, DFS is going to be required for those same key portions of the 5 gigahertz spectrum. Another point to consider is the fact that many emerging markets are still updating their frequency regulations, particularly with Wi-Fi 6E and the millimeter wave coming in. There's a lot of regulators still catching up and still trying to gauge what frequencies are best open. A great example of this is if you have a look at the 5G bands for cellular, as there's a huge variance in which bands are being opened there and how many bands are being opened. So it's really critical to keep an eye on regulatory changes and have a look at whether your product can actually operate on the bands you want to operate on before you go into that country. Another really important point is with the way technology is going, things like 2G and 3G are being shut down, other bands and things are being closed off. So as always, keep an eye on those emerging markets and developing markets as they restrict or open bands. So moving on, now let's have a look at the documentation side of things. As discussed before, as part of your EU compliance, your technical construction file is very important as it's central compliance for your product. As part of this, you've expected to have, or hopefully will have, test reports from an ISO 17025 accredited lab to help back up your product compliance alongside an EU declaration of conformity or an FCC grant if you're going into the US market. In addition to this, you'll need an associated user manual, and along with labeling and certification where needed. For outside of North America and Europe, national regulators are going to want to see this technical construction file with all of this documentation included, particularly those that are happy to leverage your existing documents for certification. For countries where English is not spoken, you will need a user manual in the language for that of that country, specific to their regulations. So your user manual does need to be tweaked and altered to fit every country. Oftentimes, as part of the certification, the regulator will want to see that user manual with all of their required regulatory wording before they will even contemplate reviewing and issuing you with a certification. So you need to make sure that you have all of that in place before you start going into a certain country. Now, ideally, we'd love for you to reach out to us so we can do a tentative search of what the requirements are and what documentation you would need. So we can help tie all your testing and your certification together so they all align with the countries you're going to get certified in. However, we appreciate and understand that is not always the case for various reasons. However, do be careful when you're splitting your test load across different test labs. So we're going to just have a quick look at what we would expect as a global market access team to see in your test reports before proceeding with certification. So of always, first and foremost, please get your testing done at an accredited lab. There are many, many regulators that will not look at test reports if they're not from an accredited lab. While it's something that you can kind of skim on by without for EU compliance, just with some kind of third-party analysis. If you're looking to actually do certification, an accredited test lab is mandatory. Additionally, we've touched on this before, but in terms of model numbers and part numbers, while it's really important to list your model number in your test report. And list it in every test report. If you're going to different test labs and doing your safety of one lab and your RF and EMC with another, it's your responsibility as a manufacturer to make sure that your model numbers are the same in every single test report and your model names are in every single test report, as long as all the other basic information. If there is a slight difference in model number from one test report to another, regulators are going to raise that as a big flag and potentially not certify it. Some regulators are very, very live and die by test report information and will only issue certifications, on the basis of what's in the test reports. So this can potentially then cause problems for you further down the line, because you're trying to certify a product with model number ABC and your test reports say ABCD. And as a result, your labeling and your certification is not going to match, which is then going to cause issues with customs. Additionally, carrying on one point earlier in this webinar, if you have a variant of the product, please ensure all your variants are also included in the test reports. This makes it a lot faster for regulators who permit family approvals to confirm that they are the same product and they have the same technologies and same specifications, so they'll issue the certification with all the variants you want included. Moreover, if you're updating your documentation as you go, make sure that your new test reports represent your earlier test reports, so that you have a full narrative and traceability through your compliance documentation, so regulators can clearly see what your compliance journey has been. So now that we've covered the essential points regarding global certification, we're going to have a look at the sort of the common pitfalls that pop up, I think is the next point. Yep. Moving on, the first and biggest mistakes that we've said before is manufacturers overlooking the regional or regulatory differences. As discussed before, when reviewing frequency planning and module considerations, regulations will differ with factors like RF power limits and labeling requirements. So before you begin selling in a particular country, please thoroughly assess whether your product can actually comply with the specific regulations and determine what amendments such as firmware changes you may need to do to ensure compliance. The second pitfall is failing to keep up with the evolving regulations. Regulations are not a static beast. They can and do adapt to the latest changes and market developments, so stay informed on those changes and can mean you prevent delays and avoid needs of retesting. For example, last year, China recently updated its Wi-Fi and Bluetooth standard. This means that for all products tested under the old standards, you now need to retest on the new standard. And your certifications will expire, I think it's at the end of next year, so even if you've had a 5-year validity obtained last September. So if you have obtained an old approval, do have a check now to see what retesting you will need to do. The third common pitfall is failing to account for component variations. Even the smallest changes like swapping an antenna or a semiconductor, as many have had to do, can alter the RF and EMC characteristics of your product. This can trigger the need for recertification in every country where your product is already certified. So even if you're tweaking components such as the enclosure, it's really important to keep this in mind. Now let's move on to my case study as a whole. But yes, overall, just make sure that when you're doing component changes, have a look at what's going to trigger recertification, have a look at what the impact on test and certification will be, and overall just have a really strong control process in place to ensure that your component changes have a minimal impact on your product development as you go along. So yes, now we're on a case study. So my hypothetical product today is my made up product, Smart Connect Home Hub, that I have put Wi-Fi and Bluetooth into, along with voice integration. For my Smart Home Hub, I first ensure that I'm going to have a look at modules. I'm first going to have a look at potentially, I've got two choices, essentially. I can either go with a pre-certified module from a well-known module manufacturer, or I can develop the product myself. Given that we only have 45 minutes here today overall for me to talk, I'm going to go with a pre-certified module for speed, which means that I can get global certification faster and reduce my testing and certification time. I'd also need to make sure that I'm disabling my channels and things accordingly. As we can see here, these are the countries that I would like to go into with my product. Fortunately, 2.4 gigahertz is compliant across all regions, with a few, depending on where they align. Most countries will align with Europe or US in terms of the channels, so it's just important to just have a quick check there. But in terms of 5 gigahertz, we've got a little bit more things we need to consider. Because I've chosen a pre-certified module manufacturer, their firmware should already have this considered, but module manufacturers tend to cater for the lowest common denominator in terms of the regulations. There are a lot of module manufacturers that will cater for the indoor use of a product, or if it's a household product, there might be certain different regulations in place compared to those of you who are going into enterprise or industrial environments. So whilst those power limits and those frequency bands are configured, do have a check of the software anyway and see whether there's a way that you can really max the use in that country so you can get maximum usage for your customers overall. But so I will be making sure that I took this into consideration when looking at these countries over here, particularly with Europe having band 4 closed, Canada, Mexico, and Malaysia having certain channels that need to be shut down, and China having a whole band shut down in band 3. So once I've ensured that all my firmware is good, I've then hit a bit of a roadblock in that my antenna manufacturer has stopped producing the antenna that I have installed. So as a result, I've had to switch to a new antenna and conduct retesting for RF. And as a result, I've had to but I haven't actually got to the certification stage yet. I'm still in the configurement stage. So whilst I might have to do few more tests, I've caught it nice and early and hit it on overall. So overall, my key takeaways are: I've picked a pre-certified module, I've ensured compliance by adapting the firmware with frequency planning, and by being proactive where possible and monitoring components supply issues early, I can avoid some costly delays further down the line. And as a result, I've managed to go and get certification nice and quickly. So, best practices. Number one, identify your target markets earlier. It's not about identifying the countries that you're going into in the next 2 or 3 years, it's the countries you're going to go into the next five years. By factoring them in at the start of your compliance journey for your product, you're going to have a much less painful journey to compliance in those countries further down the line. And then, yeah, planning for global certification in those regions so you can meet those needs. Additionally, having a look at what risks you might encounter further down the line, what regulatory changes are happening. Are you using an older technology such as 3G or 4G? How is that country looking at using those technologies? Is it something they're potentially looking at wrapping down at some point in the next year or two? So potentially you might want to include 5G in your product. So it's making sure you can mitigate those risks so you can ensure that your product is compliant where possible. And again, with global harmonization and regional customization, some products may need adjustments to meet those specific regional requirements, whether it's frequency bands or power limits, so you can avoid your redesign costs further down the line. If you can plan it all in at the start with your initial redesign, it's so much easier. Next, using pre-certified modules or modules with a limit degree of certification already in place. It will simplify your process and time to market if you need to prioritize that. And as always, maintain consistent documentation. Please, please, please include model numbers in your test reports and keep it consistent and include all your variants. We have, as a GMA team, struggled a lot with manufacturers who have included part numbers in the test report, and it has meant we've had to do 10 certifications when we could have done 1, and it hurts us just as much as it hurts you to do them. Overall, try and streamline your feature modifications as well. If you do a modular design with your integration, it's much simpler to pick out the components and change them in for similar ones, which means that it will be a lot easier going forward. So, next steps. Overall, if you haven't already, start reviewing your current product development plan. are your compliance and certification process integrated early enough that you can get to the market, so get to all the markets that you want to, and have all your future markets being considered. Engage with testing and certification experts early. Connect with certification bodies like TÜV-SÜD or test labs like TÜV-SÜD to ensure that you are on the right path and you have a plan in place that will work for when you do eventually move forward with them. Maintain clear documentation. Make sure your test reports, user manuals, block diagrams, everything is labeled to the nth degree so regulators don't have to go searching for your product details when they do eventually do the certification. And as always, stay up to date on regulatory changes and as evolving regulations can and do impact your product's compliance. For those of you who are interested in learning more about this, we will be doing a webinar in December to wrap up everything that's happened this year and touch on what's happening next year, which will hopefully provide you with a bit more detail. So overall, plan early, think globally, and be consistent in your documentation. So, and with that, it brings us to questions. So moving on, let's have a look at the questions. First of all, we've got questions about certification processes in the Middle East. Now, in terms of Middle East, they align a lot with the EU. They will accept your EU documentation. If you want in more detail, there is a webinar which we can share in a link afterwards with you on the EMEA region, which covers in detail specifically what each and every country will require from you. BIS certification of portable lithium-ion batteries on the Indian market. We can absolutely help with that. We have a great team in India who can carry out the testing and the certification for that. So if you have a specific product in mind, do get in touch and we can help you arrange a quote. And in terms of LTE bands and local operators, as I touched on before, there are millions of different variations on which bands are open. If you have specific countries in mind, please get in touch and we can help you give you a breakdown and help plan for those countries. And I think that is everything for questions today, which wraps things up nice and quickly. But I'll leave you guys for a minute to see whether there's any other questions, but otherwise I will leave you guys to it. So thank you very much for joining us, and all the best. Have a lovely afternoon.